Okay, why don't we get started now? Welcome back. I'm Brett Milash from the CHPC presenting today. This is part 2 of our 4-part Introduction to Linux series. My colleague Wim Cardone is at the back of the room here, and he'll be answering questions as well. And at any time, if you have questions, please feel free to chime in. So was everybody here who was here last week? Were you here, sir? No? I've got a handout for you. Do you have a CHPC account? You do? Okay, great. So you can log in using that. So I'll go over the instructions quickly to get everybody logged in again. So for our class today and also for next week, we'll be using a machine here at the CHPC that's named linuxclass.chpc.utah.edu. And here on our CHPC webpage, if I go back to our home page here, we scroll down on the left-hand side of the page, there's a link to our hands-on intro to Linux class. So if you click that link, that brings you to this page here. And scroll on down, and we have 2 links up here, introlinux1.pdf. Those are the slides we'll be completing today. And there's also this shell reference.pdf. We'll be going through a lot of the commands on here. And for the people in the classroom here, I've already handed out a printout of that. We'll be touching briefly on a text editor today called the VI editor. I'm just going to introduce that very, very briefly, but we will be conducting our class today using a little lighter weight, easier to use editor called Nano, which is a really simple tool that you'll enjoy using. And then we'll get into Linux scripting. So this will be this set of slides here, Linux scripting 1, and our scripting cheat sheet, which is another of the handouts that I just gave out. And if we have time, we'll get into Linux scripting 2, the advanced scripting. If not, we'll just complete that stuff next week on Tuesday. Okay, so to get logged in, I encourage you to open this, this set of slides. This is the introlinux1.pdf. And on page number 3, there's a section here on getting started, log in using FastX. So I encourage you to follow these instructions here. So the simplest way to log in is simply copy this URL off the page, linuxclass.chpc.utah.edu:3000, and go into a new window in your browser. Paste that link in and hit enter. So this starts a tool called FastX. This is a web-enabled login system that's really a great tool that we use at CHPC a lot here. So type in your unit. So I'll type in my unit here. If you don't have a CHPC account, type in the temporary accounts that we handed out, user 01, user 02, and so on. So I hit the tab key, and that takes me to the password field. So now I can type in my password. You should type in your password and hit the login button. So that will start up the FastX session and will bring you into a window that looks like this. Now you can see here, I have a session that's already running. If I want to start a new session, I can just hit the launch session button. And that brings up this little menu here with a few different icons. So hit this icon over here on the right, sort of the center of the window. It says XFCE4 terminal. I select that and hit the launch button. And that brings up a window, in a new web browser window, that has me logged in to a terminal window on the Linux class machine. All right? So for a lot of our demonstrations today, I'm going to be using a terminal window from my Macintosh, which is another way to log in. I've just used the SSH command to log in inside this terminal window. And the reason I do that is so that I can have this terminal window up as well as the slides, but the environment that I'm working in is identical to what I have if I'm logged in via FastX. All right, so back to our slides. So last time we made it most of the way through these slides. We were finishing up these file commands. These are on page 18 of the slide deck here. And we had gotten through most of these commands here, except for the last one on the page, which is the RM command. So this is a really important command. I didn't want to rush into it at the end of our last session. So what RM does is it deletes a file or multiple files. And unlike a graphical user interface machine like my Mac or your Windows machine, there's no trash bin. There's no trash can where removed files sit temporarily until we decide to remove the trash, which ultimately deletes the files. When you use RM to delete a file on Linux, it's gone, okay? So be very, very careful with this command because you can do real damage. You can remove files that are very important to you. And if you don't have a copy or a backup somewhere, you're out of luck. They are gone. So the way this works is you type the RM command followed by the name of one or more files that you'd like to delete. So I'm going to demonstrate here. Here I am in my home directory. I have this intro Linux 1 subdirectory, which is a bunch of files that we've been playing with for these exercises. So I'm going to first use our copy command to make a copy of one of these files. I'm going to copy states.dat to states.backup, for example. And I use the ls command, and I can see here's my new backup file right here. So what if I want to get rid of that backup file? I simply rm space states.backup. And I hit enter, and it's gone, okay? So it is gone for good. So you recall last time we played with the rmdir command to remove a directory. So I'm going to use makedir mkdir, and I'm going to create a directory, testdir. And so there it is right here on the right. And I'm going to copy a file into it. Let's copy our states.dat file into the testdir directory. So now when I cd into testdir and I use the ls command, I can see that states.dat is there. All right, so let's go back up one directory now. So we're back in my intro Linux 1 folder. And if I try to rmdir the test directory and hit enter, rmdir won't do it, right? Remove dir will only remove directories that are empty. But how about rm? Let's try to rm testdir. Okay, it complains. It's saying it's a directory. I can't remove a directory just with a plain rm command. So if you'll recall last time, we used the cp command with the -r flag to recursively copy directories and their subdirectories and subfiles. That same -r flag works with rm as well. So observe, rm-r testdir. Okay, no complaints, no errors, no nothing, and we look, and testdir is gone. Contents and everything. So as simple as that, you can remove a directory, its subdirectories, and all of their contents with one command. So that's a dangerous thing, right? With one command, you could remove all of your files in one fell swoop. So be very, very, very careful with this command because you can do some real damage. But it's very powerful too. You can do a lot of work if you're trying to clear out some stuff. All right, so any questions about the rm command? Okay. Okay, oh, I should, before we go any further, I should help our newcomers catch up to speed here. We have some files that we've been playing with for these exercises, and I'd like to encourage you all to take a copy of these so you can play with them in your own account. So I'm going to cd to my directory and type the ls command, and this lists the files that I have in my home directory. So I'll encourage you to do the same thing. Is everybody logged into the Linux class machine? Great. So if you type ls, do you see anything called intro Linux 1? No? Okay. So here's how you can get a copy of this. We're going to use the cp command, which is the copy command, to copy this directory from my home directory into yours. So first type cd and hit enter. Okay. That changes you to your home directory. And now type pwd, that stands for print working directory, and hit return or enter. And you should see something like this, /uufs /chpc, et cetera, /common/home, and then your login, whether it's your unid or your user 0 number account, okay? So you should be in some place. So does that work so far? Great. So now execute this command, cp space tilde u0 424 091 / intro Linux 1 space period. So let me explain what I'm doing here. I'm using, whoops, let me back up. I made a mistake. CP minus R space and all that stuff. All right, so let me explain what this command is doing. We're using the copy command, CP, minus R. So we're using copy in a way so it will copy directories and all of their contents as well. And the directory that we're specifying to copy is this. So tilde U0424091. So this specifies my home directory. That tilde letter, that tilde character is Linux shorthand to say the home directory of whatever. So I could say tilde user01 or tilde user37 or tilde and this unit, which is my unit. So I'm saying from the home directory, copy intro Linux 1. And so that's this directory right here within my home directory. And then I have to give copy a destination. Where am I copying it to? And so this final character on the line, the period, is Linux shorthand for your home directory. Okay? So go ahead and execute that command. Hit the return key. It should make a copy into your home directory. Now, I can't do it myself because I already have that directory here, and it can't copy it into the same place. But when you then type ls, you should see intro Linux 1. So did that work for everybody? Yes? Does that work for you?
I'm working on it.
Okay, great. Okay. Mai, how about you?
I have an error that doesn't listen to the file.
Okay. Did you put the period at the end of that command? Okay. Yep. You have to tell it where to go. So that command again was copy tilde. I'm sorry, copy minus R tilde U0424091 slash intro Linux 1 space dot. And so it's saying copy that intro Linux directory 1 from Brett's home directory into your home directory. Okay, you good, Maya? Okay, yep, the spaces are crucial because every Linux command, when we're working in the shell, every Linux command is looking for space-separated words, space-separated things. They can be one space or many spaces, but there's got to be some spaces between. Okay. Okay, I think we're all good. Great. All right, so all of the commands that we've been playing with here, so head and tail, less, grep, and so on, we've been working with individual files. And that's fine, but sometimes that gets tedious when you want to work with multiple files. So let me show you an example here. I'm going to cd space intro Linux 1. Now I'm going to type ls. And notice here in this directory, we've got a bunch of C language source code files. So file.c, program.c, there's a couple others, new.c, and so on. So why don't we look at one of these, less new.c. So this less command, if you remember from last time, is a file viewer that shows us the contents of a file a page at a time in a nice way. So I type less space new.c, I hit enter, and it shows me the contents of that file. And so if I want to page down through that file a page at a time, I can hit the space bar, and it'll do that till I get to the end of the file. If I'm done looking at that file, I can just type the letter Q, and it kicks me back to the shell. So that's the less command. All right, so let's go back in here, look at we're going to use less to look at new.c. And I'm a C programmer, so I'm looking at the C code here, and I can observe that there are a bunch of include statements in my code. And I think, okay, that's interesting. I wonder what all include statements are found in this file, and we can go and do that. We can use the grep command. So last time we talked about grep, it's a pattern matching tool that will search one or more files for a pattern of letters that we specify. So I can say grep include space new.c. And I hit enter, and it shows me on the screen all the lines from new.c that include the pattern include, okay? So, but what if I want to search all the .c files? That would mean I'd have to specify them all. I'd have to say grep include new.c and full.c and so on and so forth. There might be 100 files here whose name end in .c, and I'm too lazy to type them all out or figure out what they're all called. So the Linux shell provides us this capability called a wildcard, which is the ability to use special characters to specify multiple files at the same time. So we can put these special characters together in different ways to create complicated patterns to very carefully pick and choose which files we want to see. And we can specify those patterns, those wildcards, in a way that save us from typing in all the different file names that there are out there. So here are a couple of those special letters. The star character, so on my keyboard, that's on the 8 key. That matches any numbers of letters at all. So any number of letters can be represented by that star in a wildcard. So let's go try that. So I'm just going to try that with the ls command. So if I ls, it prints out all the words. If I ls space star, that also selects all the files there are in the directory, because star matches any number of characters any times. So that matches everything. But let's narrow that down a little bit. Let's ls star.c. So this will match any file name that has any number of characters but ends with a .c. So if I type ls space star.c, now I can see I just have full.c, new.c, and program.c. So likewise, we can use ls, for example, f star. So that matches what? Any file name that? Exactly. Starts with an F, but has anything after it. So if we type ls f star, then we see figure1.jpg, figure2.jpg, figure3.png, and so on, right? Everything that starts with an F. Let's see, let's go back to our files here. So question mark matches any single character, right? So let's go try some patterns that do that. So let's ls, let's see, I see, for example, there's a bunch of pi3 underscore ser files. So let's try to find them all. ls pi3 underscore ser dot question mark. So that'll match anything that begins with pi3 underscore ser, but ends, oh, ls, whoops. Thank you. ls pi3 underscore ser dot question mark. So there's an ser.f, there's probably some Fortran code, and there's an ser.o, which is an object file, which is compiled Fortran code. All right, so there are a couple other handy wildcard patterns. These square brackets allow us to enter between the square brackets any number of characters. And so that thing in the square brackets represents an occurrence of one of those letters. So let me show you an example of this. We can say ls bracket A, B, C, D, E, F, G bracket star. So this will be any file name that begins with one of those letters, A, B, C, D, E, F, or G. And there they are. We got A, we've got C's, we got F's, we got G's, and so on. And so you can mix and match these different types of patterns to do all kinds of interesting things. So another thing we can do with these brackets is if we're looking at a range of consecutive characters like A through G, we can simply say A-G within the brackets to narrow it down to a subset of the alphabet. We can say A, E, I, O, and U. So we can find all of the file names that begin with a vowel. And there's simply one of those. All right. So if we're using, so these wildcard patterns are not limited to the ls command. These apply to all commands in the Linux shell. For example, we can grep include from star.c. So here the shell is identifying the files that end with .c, and it's passing those file names to the grep command to be searched. And so we can see we found some includes in full.c, we found some includes in new.c, and we found some includes in program.c. So remember, with any Linux command, anytime you're specifying a bunch of files, you can use these wildcards to simplify your life, so you don't have to type out all of their whole file names. Okay, questions about that? Yes. Sure.
When do you need quotes? And when do you-
Yeah, that's a great question. You need quotes around the pattern that you're searching, for example. If the pattern contains letters that the shell is going to misinterpret. So for example, $ has a special meaning in the shell, right? We use that to look at a variable. But what if you want to grep $ from the file, right? You want to sort of protect that $ character from what the shell is doing. So here's another example. Spaces are very important to the shell. The shell uses spaces to break up separate parts of a command. Well, what if the pattern you're searching for with grep includes a space? So you would put your whole pattern, spaces included, within quotes. And so it sort of protects those spaces, those special characters, from the shell.
Is that unique to that, or would that also?
No, it's unique to any shell statement. So whenever you have an argument to a shell command that contains special shell characters, $, quotes, slashes, spaces, things like that, you need to put those things in quotes. And it never hurts to put things in quotes. It's always a safe thing to do.
So, I mean,
You really can put everything in quotes. It's tedious, but you can absolutely do that. Absolutely. Yeah, great question. Okay. All right. So here's some examples of using wildcards. So star.csh, so that's any file name that ends with .csh. Star dot, whoops, whoa, what just happened there? Something very odd just happened to my keyboard here. I'm not sure what I just hit, but my keyboard kind of freaked out. Okay, so figure question mark.jpg. So in this example, you would match any file whose name begins with the word figure, has one letter followed by .jpg. Remember, question mark matches any single letter in a file name. All right, questions about wildcards before we proceed? Okay, great. So wildcards are a great tool, really convenient way to get a lot done without having to type a ton of file names. All right, so let's do an exercise together. So you should all have an intro Linux 1 directory in your home directory by now. And so let's go through these step by step. Or why don't I tell you what, why don't you all work on these independently? Let's take a few minutes, say 4 or 5 minutes to go through this. If you get stuck, raise your hand and we'll come around to help you out. And then we'll proceed at 1:30. And so many of you already have an intro Linux 1 directory. And so you don't really need to copy over the contents again, since you already have that there. Nope, I don't see any either. Yeah, a student named Manish wrote to me privately and they're asking for something. But
Oh, that's maybe the reason, because I couldn't see it.
yeah, but I don't see any other messages.
Because I don't see it, right? It's a ministry of chat and like that.
So I figured we'll get through this stuff quickly. We'll do the first part of the scripting. Might be able to start on the script.
Hopefully some of this project. I haven't been working on spec. Everything.
Yeah, that's true. It's really true.
So do you know people who work as
No, everyone I knew working at the Cancer Institute was using AWS. There were a couple people who had joined us from the Broad Institute who were familiar with Google Cloud, but not very many. For sure.
Many of these companies like
Yeah. So there's a genomic company that we were working with called Seven Bridges Genomics. Their whole platform is built on AWS. I honestly don't know how much use that's getting. I think mostly people are using it just for cloud storage.
I also heard that they use it for video for the industry.
Yeah.
Let's say one of the research groups is a project for the industry. And this thing is that we can do beyond how much it costs to the computer. Yeah. It's more than just story.
That's right. Yeah, so like hidden overhead costs and stuff like that. Yeah. That makes sense. Okay, it's got 1:30 minutes to go. Okay, so that's a few minutes. Any questions about that exercise? Okay, yes.
So, well, in this case, so the -A, that file just means if it exists, right?
So the -A flag includes the so-called hidden files, which are files that begin with a dot. So
And also once again, the tilde, right?
the ending with a tilde shouldn't hide a file necessarily. There are some files that begin with a dot and end with a tilde. And those are files that that would also be hidden because they begin with a dot. A really interesting thing to note here, when I type, so I'm in my intro Linux 1 directory, and I type ls-a. So this is showing me not only the regular files, but also the hidden files that begin with a dot, or here's another one that begins with a dot. So this file that begins with a dot right here, which is simply dot, what does that represent, that particular file? That is our current directory. So dot is Linux shorthand for the directory where we are right now. So I can cd space dot, and I type enter, and I'm still in my intro Linux 1. So dot is an actual directory. It's the name, that is its name, and its location is the directory where we are right now. So this idea of copying something to dot, for example, right? You're actually copying it to a real directory, and it's the directory where we are right now. Then there's this directory called dot dot, which you notice right here, right? Dot dot is another directory, and it happens to be the parent directory, one up in the hierarchy from where we are now. So in my case, right now I'm in intro Linux 1, so dot dot refers to my home directory. Well, dot dot is an actual directory entry where we are. And that's just how the Linux shorthand works to reference the parent directory, one up from where we are. So it's kind of interesting to see. That's not a magic, a magic thing in the shell where the shell is saying, the shell isn't trying to figure out with every single command when I use dot dot, for example, in cd space dot dot. It's not trying to figure out, oh, did Brett type dot dot? Oh, that must refer to, the parent directory or wherever he is. It's an actual directory whose name is dot dot, and it's just a link to the parent. So it's kind of cool in my opinion how simply that's implemented by having a directory called dot or dot dot in every directory you go to. All right, so that's that exercise.
One format, so the A stands for all.
Yes,
So for hidden and multiple.
ls-a, yep. And we can see ls-al, for example, if we do a long listing on all the files, you can see that dot and dot dot those entries here begin with a D, saying these things are directories. Okay, so let's move along here. Let's see. Okay, here's more of this exercise. So within our intro Linux 1, there's a file called script.slurm. And so let's play with the cat, less, head, and tail commands on that file. All right, let's do that together. So I'm in my intro Linux 1. There's a file called script.slurm. And so I can simply cat script.slurm. And that shows the whole contents of the file up on the terminal window for me. So cat simply takes a file or files and sends it to its output, which is my terminal. Okay, so we can use the head command. So head script dot, whoops, let me type that correctly, script.slurm. So head script.slurm just shows me by default the first 10 lines off the top of the file. But we can change that. We can say head-1 of script.slurm, and that just shows me the single first line. Or we can say head-3 script.slurm, or head dash however many we want. We could say head 5 million of script.slurm, and it will show me up to 5 million lines of input. But it's not that long, but it shows me what it can. Okay, the same is true with tail. So tail script.slurm, that shows me the last 10 lines off the tail end of the file. And similarly, we can say, whoops, tail-3 script.slurm. And it just shows me 3 lines off the tail of the file. All right, so those are really convenient commands when you're dealing with big files, like big data files. Let's say you just wanted to see the very beginning of the file or the very tail end of a log file or something like that. You don't have to look at the whole file. You can just look at bits and pieces using head and tail. All right, so let's search for the string sbatch using the grep command in that same script.slurm. So how do I do that? We use the grep command. So how do I search for a particular pattern in the file? So I give it the pattern name, sbatch, and then the file name I want to search. So grep sbatch script.slurm. And so grep shows me all the matches from that file that contain that particular pattern that I'm looking for. So grep is a tremendously useful command. If we look at the manual page for that, and we use the man command to look at the manual page, man grep. So this puts us into the viewer looking at the manual page for the grep command. And we can see the general synopsis for this. Any grep command starts with the word grep. And then we have some options, and those are optional. We don't have to give it any options, but we can. And then we give grep a pattern. In this case, we used the word sbatch. And then we gave it 1 or more files. So let's take a look at some of the options for grep that make it do really useful things. So if we scroll down here, we can do things like, let's see, this is a really useful one, grep -i. This makes grep case insensitive. By default, it's case sensitive. So let's go play with that real quick. So if I grep capital sbatch from script.slurm, you can see I've got a bunch of matches here. I have half a dozen matches here that match capital sbatch. But if I use lowercase sbatch, script.slurm, I get nothing, right? There's no occurrences of lowercase sbatch in there. But if I grep -i, case insensitive, sbatch from script.slurm, there they are. Because we're not caring if these are uppercase or lowercase. So grep is one of those commands where these options help you modify its behavior to do whatever you want. All right. So whenever you're working with a command and it's not clear to you how to use it or what it's doing, remember that man command. Man anything will show you the manual page on these commands. It's a tremendously useful tool. Okay, here's another thing we can do. So we have a file here called shellreference.pdf. Let's see here, ls space shell reference dot, oh, there's one called jpg. Let's use that instead. So shell reference.jpg. So you recall last time we used a command called file And let's ask, what kind of file is this? So its name suggests it might be a JPEG file. But no, shellreference.jpg is really a PDF document. It's not a JPEG file at all. And so recall from last time, the file names that we use are a convention to help us understand what are the contents of those files. So typically a file whose name ends with .c is C language source code. And a file whose name ends with .txt is a text file of some kind. But it doesn't have to be that way. That doesn't have to be so. Just because something ends with .c doesn't mean it's necessarily C source code. That's just a suggestion from the creator of the file to say, hey, this is probably some C source code, just as this file is probably a JPEG file. But when we examine the file with the file command, we discover that no, it's not JPEG, it's actually a PDF. So we can copy that file now. Let's copy shellreference.jpg to shellreference.txt, for example. So does that make that new file a text file? Let's try file shellreference.text. No, it's still a PDF file. So the name of the file doesn't dictate what the contents of the file is. It doesn't dictate what this thing is. It's still a PDF document. All right. And again, that file command is a really powerful tool for us to figure out, like, what are the contents of this file. It's a safe way to look into a file to figure out what it is. All right, questions about that before we go on? Okay, great. All right, now let's do something in the shell which is called output redirection. Now, we have executed a bunch of commands like grep and file and who am I and so on. And all of those commands have produced output that come out to our terminal, and we see it displayed on the screen. So if I type who am I, it shows me my login. Or if I type who, this shows who's logged onto the computer right now with us. And so all of those commands are producing output, and they're coming out to where we can read it on the terminal. But what if we want to do something with that output besides just look at it? What if we want to capture it into a file and save it? So this is where we use redirection in the shell to redirect that output somewhere else. So there are a couple different ways to do this. The first is with the greater than sign. It looks like an arrow. And that arrow indicates that we're taking the output from a command and we're directing it into a file. So let's try that. Let's take this who command and redirect it into, I'm going to call the file who_output. So I typed the command and nothing came up on my screen because everything that would have come up to the screen is now in that file. So now let's examine that file with less who_output. And there it is. There's the list of users that are on the machine. And we've captured that output from who, and we stuffed it into the file. All right. So here's another command, date. This shows the current system time and date, which is a handy thing. And I can type date and arrow into some file. And so it didn't come to our screen, it went to that file. So I can use the cat command, cat space some file. And there it is. Okay, so let's do that again. So I ran that command at 13:40 and 30 seconds. So I'm going to rerun the date command. So I'm using my up arrow to go back to a previous command here. And I'll run date arrow some file again. Okay, I hit enter. And now let's use the up arrow and let's cat that file a second time. And so now it says 13 hours, 40 minutes, and 58 seconds. So it replaced the old contents of the file with the new content. And so every time you use that single arrow to redirect into a file, the shell wipes out the previous contents of the file and replaces it. It overwrites it with the new contents. So remember that when you're redirecting stuff into a file and use that single arrow, you're going to blow away whatever is in that file initially and replace it with new contents. So an alternative to that is to use two arrows. Instead of overwriting to a file, this appends onto the existing content. So depending on what you want to do, you can use a single arrow to replace the contents or a double arrow to append to an existing file. So let's do that now. So I'm going to cat sum file. I have a single line of output from an old date command. So now I'll run date with 2 arrows onto sum file. So now when I look at sum file, I now have 2 rows of output. One from the original date command and a second from the subsequent date command. If I repeat that date command a 3rd time, I now have 3 rows of output from old date commands, okay? So you can just continuously append onto a file. Yes?
If you had just used one file, it would have overwritten.
Exactly. So now let's do that. We'll use a single arrow, and now we'll cat the file, and we just have the most recent output. So this is a really convenient characteristic if you have some program and you want to log its behavior over time. You can simply redirect output from that statement with 2 arrows onto a log file and capture a long stream of events that have occurred when you're running a program. So single arrow overwrites a file, double arrow appends to the existing file without changing the old contents. All right. So there's a 3rd way to redirect, and this is called the pipe. It's a vertical bar. So on my keyboard, this is just up above the return key. Okay. And so this redirects output instead of into a file, whether that's a new file or an existing file. This redirects the command output into another process, another program. So let me show you an example of that. So the grep command can grep stuff from a file. It can also grep patterns from its input, whatever its input is, whether that's a file or whether that's input that's been piped into it. So here, let's run our who command. And so that's everyone logged onto the Linux class with us. I can run who and then pipe that into grep. I'm going to grep the pattern user. And so this will find every line in grep's input that contains the word user, and it will show it to us. Okay? And so you'll see there's lots of lines like this one here that don't contain the word user. So those were excluded. But every line like this that contains the word user was included in what grep then output. So we can grep user, we can grep, let's grep. So grep can do the same kind of thing with patterns that the shell does with wildcards. So I can grep a pattern like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will grep any line that contains any one of those digits. Okay, so all this output comes out. So grep has lots of useful commands, for example, -v. So -v, we talked about -i, right? That makes grep a case-insensitive search. -v will search for, instead of everything that matches the pattern, it'll match everything that does not contain the pattern. So let's run who, and let's grep user. So here are the lines that contain the word user. So let's turn that around and we'll grep -v user, and that excludes all the lines that contain the word user. So you can include stuff or you can exclude stuff using -v with grep. So notice here, I've taken this command who, I'm taking its output, and I'm passing it through grep, and we're grepping user, okay? So those 2 things together comprise essentially another Linux command. We can now run that command and redirect that output into some other file. And so now I've taken one command, I piped it into another command, and I'm redirecting all that with my same redirection tools. So I can use arrow, I can use the double arrow, or I can use the pipe, for example, and redirect that further. So you can build up arbitrarily long pipelines of commands, piping one command into another command, into another command, into another command, into a file, for example, okay? So the beauty of the Linux system, in my opinion, is this ability to mix and match all these simple tools and put them together into ever more complex commands, right? This is one of the really great, powerful things about this. You're not limited with grep, for example, just to look at one file. You can look at multiple files, or you can look at its input coming in from another command. So all these different commands are little building blocks that let you build up ever more complicated statements. Okay? So that's kind of the beauty of redirection, in my opinion. Here's another cool command. We'll get to this one later down the road. There's a command called sort. And like grep, sort takes its output either from a file or from a pipe coming in. It reads all its input, and then it sorts it alphabetically. Okay, so we can say who pipe grep user. So that gets us this output here. We can then pipe that into sort. And so now when the data comes out, it's sorted alphabetically. Okay, so there's a myriad of different commands out there that you can use in Linux. And it's just limited only by your imagination how you put these things together into ever more complex commands and statements. It's very cool stuff. Okay, any questions about redirection before we go on? Okay, great. Okay, so we have an exercise. So down under so in the previous exercise, we were to create a work directory. I don't know that we actually did that, but you can do this in your Intro Linux 1 directory as well. And so we are asking you in your Intro Linux 1 directory or your work directory, combine the contents of the files geom1.txt and geom2.txt into another file named geom3. So you can do this however you want. You can use cat, you can use redirection, you can use any of the tools that we have at your disposal. So that's the first part. The second part is to use grep, and there's a file there named states.dat, and create a new file, mstates.dat, that only has the states whose names start with the letter M. Okay, some tricky grepping. And then try doing that same thing. Instead of using grep, use a combination of the head and tail commands to do the same sort of thing. All right, so that should take a few minutes. So it's 10 till 2. Why don't we take 5 minutes and work on that? And raise your hand if you get stuck. Yeah. Okay, that is a great little problem. So what's going on here? You're grabbing M star from states like that. Right? So what is M star expanding to in the shell? That star is a special character for the shell. You asked earlier about using quotes. For regret pattern, right?
Okay.
So the M star is expanding to something in the shell, right? Because the shell sees that star and says, "Oh, this is a." She's using a wild card. It's going to try to expand that out into something.
I see. Okay.
So in this directory, we may not have any files that we can anything out. So that may not expand to anything at all. And so the command that the shell produces after interpreting the wild card is grep nothing from state stuff. And so that's not a complete grep. It's expecting more something. So it's just kind of hanging there waiting for something. Yeah. So by putting in quotes, it checks the error.
So then, so yeah, it's still,
Still doing something.
alright.
So what happens when you just grep capital M from states like that? Is that the star?
Oh, because it's case sensitive, right? Alright, that makes sense. I was worried about.
So you're getting the Maryland messages also, but you're also getting New Mexico, which doesn't start with the number. So somehow you need to make your pattern more specific to include the things that start with the noun, but exclude things that contain a noun, but it's not necessarily have to start with it.
Okay, so I can exclude space then,
Yeah.
right?
Yeah. So you could grep M and then pipe that into grep dash V space or space or something.
Okay.
Or there are other ways as well. So check out the man page on grep.
Okay. And then what is the third exercise?
So we'd like you to create a new mstates.dat file. But instead of using grep, use head and tail.
Okay.
So somehow manipulate states.dat with the head command and the tail command.
Oh, all right.
That results in
Yeah.
exactly.
Okay.
Okay. All right, that's about 5 minutes. Why don't we talk over solutions to these and talk about problems that we ran into with these commands. Okay, so the first thing we're going to do is we're going to use the geom1 and geom2 text files and combine those into a third file named geom3.txt. All right, so here I am in my intro Linux 1. For some reason, my terminal window is not working. I'm going to terminate that and open a new terminal window. That's weird. Okay, so I'm back in my intro Linux 1, and I see I have this geom1.txt file and geom2.txt file here, and my goal is to combine them into a new file that has both of them together. So, did anyone come up with a solution for this? How did you do it? Okay, I can think of a couple of different ways. So one way is with the cat command. So the cat command takes a file or files and sends it to its output, which is normally our screen, right? We can cat geom1.txt, and we can cat geom2.txt. So we can grab the contents of those files. How can we put that into yet another file? We can use the arrows, exactly. So we can say cat geom1.txt. We can arrow it into geom3.txt. And then we can cat geom2.txt, and we can append it with double arrow onto geom3.txt. Okay, so that is a way we could do it. That's perfectly fine. So let's remove geom3.text. Another way is with cat, or another way we could do this is we could copy geom1.text and copy it into geom3.text. Okay, so we're just duplicating geom1. And then we could cat geom2.text and append it onto geom3.text, just like we did in the previous example. That would work too. Okay, there is yet another way. We could simply cat geom1.text and geom2.text and send that into geom3.text. Okay, that's probably the simplest way. So with a lot of these Linux commands, you can take one or more files as the input files and do the same thing to all of them. So in this case, cat will take geom1 and then geom2, take their contents and send it to their output, okay? And then we can redirect that however we like, in this case, into geom3.text. And so that works as well. So we can less geom3.text now, and we've got all that stuff, okay? Yes?
So I did the second way you did it.
Mhm.
And I'm surprised to hear the cat works in copy. Was there any consideration when files are much larger of what the bus processing?
Nope,
There's
copy.
a reason to do one.
There's not really. So copy and cat are, so copy is kind of doing a subset of what cat does, right? Copy takes an input file and opens a new file and writes its output there. It's conceptually exactly the same as cat geom1.text arrow geom3.text. The exact same amount of processing is happening. So there's really no difference between the two. Even if they could be any kinds of files. It's really doing the exact same kind of thing. What cat is doing is sort of a more general purpose use case than what copy is doing. So copy is restricted to taking one file and putting it into another file. Cat is taking a file and sending it out to whatever we want to do with its output, whether that's to let it come to the screen or redirect it into a file or pipe it into sort or grep or something else. But it's the exact same amount of processing. It's the exact same, at the end of the day, we're taking the content of this file and we're duplicating it into another file. And from the computer's perspective, it's all the same amount of work. It's reading the exact amount of data off the disk, and it's writing the exact same amount of data back into another file on the disk. So it's all the same at the end of the day. Yeah. Okay. So we've got some different ways, and this is a great example of how, there are frequently multiple ways of accomplishing the same thing. And when you're looking at another programmer's statements in a program, sometimes you may look at what they've done, and you might see them, copying this file and then catting another file onto it. And you might scratch your head and say, well, that's a goofy way of doing it. Why did they choose to do that? And sometimes it's not clear. Sometimes you just have to, take their code with a grain of salt and say, well, it works. Let's let it be, for what it is. Okay, second exercise, we're going to use grep and the states.dat file, and we're going to create a new file called mstates.dat. Okay, so we're going to grep some pattern out of this grep, the states.dat file. Let's go look at that file real quick. States.dat. So it's an alphabetic list of the 50 states of the USA, okay? And so our goal is to create a file that just contains the states whose names begin with M and stick those into a new file, okay? So conceptually, how are we gonna do this? We're gonna grep, give it some pattern, and then its output, we wanna stuff into a new file. So how do we do that final bit of putting stuff into the file? With the arrow, with the redirection, right? So we're gonna grep, some pattern from states.dat and redirect it into mstates.dat. Okay, so what are our options here for what this pattern is? So we want the files that begin with an M, right? So it's probably something like grep M from states.dat. So let's try that and see what happens. All right, so when we look at mstates.dat, so we have Maine, Maryland, Massachusetts, etc. We also have New Mexico, right? So we've come close, but we're not quite there. But for the rest of these, this has worked well. So let's take a look at the manual page on grep and see if there's anything in there that will help us. So we have grepped out of a file. Something with our pattern is not quite right, but we're grepping from the file correctly. So that's all working nicely. So I'm going to give you a hint here. Let's see. Let's see here. There are some special characters that we can use in our grep patterns to make our patterns more specific. I mentioned how you can use the brackets, for example, with grep to grep specific character ranges from a file. Let's see. There are characters called meta characters. These are essentially the wildcard characters that we're playing with. I'm having a hard time locating this in the manual page, unfortunately. Let's see. All right, so what we're using here is a capability called a regular expression. And there are special characters that we can use in regular expressions, this caret and this $sign, which represent the beginning of each line and the ending of each line in the patterns that we're searching for. So maybe that wasn't a fair exercise because you don't really have the tools yet to do this sort of things. But these regular expressions are very similar to the wildcards that we use for file name pattern matching that allow us to do very complex pattern matching within grep. So let me illustrate this. If we grep caret capital M from states.dat, I'm telling grep to find M's in my file, but only M's that are adjacent to the beginning of a line. All right, so that's what this caret does within a regular expression. So when I execute that, I find Maine, I find Maryland, and so on. So we can similarly use $sign to represent the end of a line. So let's say, for example, let's just grep E, the little lowercase e from states.dat. And we see E's that appear all over the place in the file. Let's say we want to limit our search to E's that appear at the end of a line in a file. So we can go back and say $sign, which means find me patterns where the E is adjacent to the end of a line in a data file. And so when we do that, it finds nothing. Why not? Oops. It's not doing it, darn it. It's making me look silly here. I'll have to figure that one out offline. Don't want to waste your time with that. Yes. Grep -E. Single quotes. No. Let's see. Treat the file with binary. Let's see. Let's try it with a capital U. It's not working for me. Well, I'm going to have to explore that offline rather than waste the day trying to figure out why grep is not working for me. That's odd. $sign then E. $sign E like so. Minus what? Big E or little e? Capital E. $sign E, $sign. Huh, that's odd. It's not working for me. Well, we'll come back to that next time. I'm really confused why that's not working. That's a feature that I use. All right, so let's see. How can we accomplish the same thing using head and tail on our states.dat file? Anyone get that to work? Okay, so let's look at states.dat. So we want to include, if we use head and tail, for example, we could tail the file from here on down. So from main to the end of the file. And then we could pipe that into head and just grab the file, the lines that begin with M. So there are, how many here? 1, 2, 3, 4, 5, 6, 7, 8. So we could grab all the lines from M to the end using tail, and then we could pipe that into head, just grabbing the first 8 lines off the file. Okay, so we could say tail dash, I'm just gonna guess, how many, 20, let's say 15 from states.dat. So that gets us, that starts from Oregon. That's a little too, I need to grep more, right? I'm sorry, let's see. 20. So that gets from New Mexico. Start tail dash 25. Okay, that gets from Montana. So let's go up to say 20. Okay. Oops, I have to go higher. I have to go to 30. Okay, so that's getting from Massachusetts on down. And then if we pipe that into head dash 8. Okay, we're getting from Massachusetts up down to Nevada. We're close, not quite. But you get the idea. Just by limiting the line number ranges, we can specify which sets of lines we want to get. That's kind of an inefficient way to do it. I think doing it through grep would be a more elegant way. Yes?
So I have a question about that. I was trying to use that dash B and then just exclude tail as point B. Is it even possible to use grep exclude with head and tail?
So head and tail, you could do that, sure. So you could, for example, if we grep M from states.dat, this gets us most of the way there. Then we could use it with head, for example, to just grab this many lines. Okay, so there's 1, 2, 3, 4, 5, 6, 7, 8. So we could grep that and pipe that into head dash 8. And so this would get just the M states because it would exclude New Mexico off the tail end of that. Oh, that's another way. We could grep M states.dat and then grep dash V new from New Mexico, right? So we could exclude New Mexico that way. That'd be another way to go, sure. All right. Okay, any other comments before we continue? Okay. Okay, let's talk about file permissions a little bit. So we saw the file permissions displayed last time when we used ls-l. So I'm going to run through that real quickly here. We're here in my intro Linux directory, and I type ls-l, and it lists all the files in a long listing that's in this directory. And there's all this business over at the beginning of the line, all this gobbledygook here, okay? So there's a lot of information that's really useful to us on this line, like the names of the files, the dates when they were created, the size of the files in characters. We also see who the owner of the file, so in this case, these belong to me, and I belong to the CHPC group, so it shows my personal, it shows who the person is that owns this, and the group that that person belongs to, or the group ownership. But then there's all this stuff at the beginning. And so this stuff at the beginning, these R's, W's, and X's, and hyphens, these represent the permissions associated with this file. Those permissions control who has access to this and who does not. All right, so the permissions for each file include the read permission, so who is able to read it, who is able to write it or modify it, and who is able to execute that file, like in an executable program sense. And there's a Linux command called chmod, or change mode, which we use to change the permissions on a file or on a directory. So these permissions that we see here are grouped into 3 sets. There's 3 letters here. These correspond to the permission on this file with respect to the person who owns the file. So in this case, me, if you look at your files, that first group of letters will correspond to permissions that apply to you as the owner of a file. The second set of letters here, R-X, this corresponds to other people who are in the same group that I am. So Wim and I both work here at CHPC. We're both in the CHPC group. So each of you belongs to different groups on campus according to who you work for. If you're a professor, you have your own user group, and so on. And then finally, there's a threesome of letters here that correspond to the permissions for everyone outside of this group, outside of the group to which this file belongs. And so when a person tries to access a file within Linux, the appropriate set of permission characters here apply to that user interacting with a particular file. All right. And again, we can use chmod to change that. So let's say, for example, I have some files in my home directory, and one of you is trying to access those files. Since you're not me and you're not a member of my group, then this set of file permissions over here that correspond to other users on the system, those are the bits, those are the permission characters that control your ability to access my files, and vice versa. If you have some files in your directory, I'm trying to access those characters there are going to control my ability to access your files. All right? And so when I create, let's go back to my home directory, and I'm going to create a new directory called test directory. So when I do an ls-l, I see my new test directory here, and I can see that I have the ability to read and write and execute any files within that test directory there. So that's what this first RWX means. So Wim, who's in my group here at CHPC, he has the ability to read those files. If those are executable programs, he can execute those files, but he can't write to that directory. He can't modify it by creating new files there. And if he tries, he'll get the permission denied error. Likewise, there's an R and X over here. This third group corresponds to all of the rest of you with respect to this particular directory. So if any of you tried to go in and create files in this test directory, you'd get the permission denied flag, the permission denied error, because you don't have write permission there. All right? So I can use the chmod command to modify those permission settings to either allow you folks to create files in that directory and so on. So let's give that a try. So I'm going to chmod plus W. So I'm adding the write permission to the test directory. So whoops, let's see, chmod go plus W test directory. Okay, so now I use the command chmod G and O, groups and others. So Wim's in my group, you all are others. I added the write permission to that test directory. So now when we run ls-l, you can see that there's read and write and execute permission for me, for the people in my group, and for people outside my group. So I can also say chmod others minus W. So for other people, I'm removing the write permission from the test directory. And now you can see I have removed write permission for you all from this directory. So you all can do the same sort of thing. You can create directories, and then you can grant or remove the ability of others to write in those directories or to read and get files from those directories. So this is really important when you're trying to collaborate with other people. Typically, when you create new files, other people can see them, but they may not be able to write in a directory. Let's say you create a directory and you want your lab mates to be able to put files there so you can collect all the work in a big collaborative thing. Well, if you create a directory but don't grant people the ability to write there, they won't be able to do that. And so this chmod command is the way you do this, okay? So this being an academic computing center, things are generally kind of open. The default permissions that we have on files is generally for people to be able to read them, but not to be able to alter them. And so when you create a new directory, by default, other people will be able to look at those files. But what if you want to create a directory that no one else can look in? Here's my test directory Other people can read those files. I can chmod others minus rwx. I can remove all permissions from other people here. Oops. And so now people within my group can read, write, and execute in that directory, but people outside my group can't even look in there. They don't have permission. Or I can chmod g minus rwx. And so now not even the people within my group can look in there. No one can look in there except for me. So you've got complete control over the access to your files on any Linux system this way. And that chmod command is the way to do that. Yes?
So if you don't include a G or you're changing permissions
For yourself, yes. Yeah. And so you can change permissions for the user, and that's you, for the group, so those are people within your team, and O is everybody else. You can also use A, and that affects globally permissions for everyone. So why would you create a directory that you can't read or write or execute?
you might have copied it from somewhere else and it comes with those permissions.
Exactly. So something that I do sometimes is I'll make a backup for myself of critical files, and then I will remove write permission for myself so that I can read the files, but I can't modify them. So I can't mistakenly go in and delete them or do something silly like that. That's about the only time I do that sort of thing. It's kind of an unusual situation. Mm-hmm. Yeah, another way to do this, if you look at the manual page on chmod, let's see. I'm not sure they go into this in the manual page too much. There's a way to think of these permission letters in terms of numbers. They do it in base 8, which gets a little strange. So the reads are the way this is implemented in the file system is actually as bits or as numbers. So you can think of the R's as 4s, and the W's as 2s, and the X's as 1. So I can say, for example, chmod 777. So this is base 8 for 4 plus 2 plus 1. And when I do that, you can see that I've turned on all the permission bits. Or I could do something like chmod 770 on test dir. And so now, that 7, the first 7 represents the read, write, and execute permissions for myself. The second 7 represents the read, write, execute permissions for the group. And the third 7, or the third number, third digit, represents the read, write, execute permissions for others. So it's a shorthand way of doing that if you like doing it that way. Anyway,
1, 2, 4.
that's right. Yeah, so 1 for execute, 2 for writing, 4 for reading. And so those are the first 3 bits, essentially, in binary or base 8 numbers. Okay, so that's chmod. Chmod is used for controlling permissions on directories like this. It's also used for controlling whether or not you can execute files and programs and scripts. So when we get into more scripting, we will get into that stuff more. Okay, so let's move on and talk about something in Linux called processes. So within a Linux operating system, whenever you're running a task, that task is called, in the Linux sense, a process. This is just an activity on the computer. And every process that is running has its own unique ID number, or a PID, a process ID. And there is a command in Unix or Linux that reports a snapshot, essentially, of all the processes you have running. And that's PS. It stands for process status. So let's go into our shells here and just run PS and hit enter. And so this is showing that I'm currently running 2 processes. I have a bash process. That's the process that is my login shell. And I have the PS process. And that's the actual PS command that I'm running right here. So each of these processes has a unique ID number. So my login shell has the ID number 22862. So this just shows the activities that I'm currently running at that moment in time on that particular window. So you can look at all the different processes running on a Linux machine, and there are a bunch of different flags in PS. So PSAX, for example, to look at the processes of different users or of all the different things that are going on. And we also have the ability to kill these processes. So this isn't something I recommend willy-nilly, but you have the ability to start processes and then kill them off.
One small comment. So every time you have a Linux command, we have options, we use the hyphen, right?
Mm-hmm.
So with the PS, the AX, EWX install, there's no hyphen. And there's another one, PS minus, yeah, there's one over there. And the reason is that for this PX command with this AX and stuff like that, it's actually a BSD Unix.
Yeah.
That's why they don't use, and that's the only case where I know there's no.
Yeah, this is one of very few cases, and I can think of tar as another one, where the options, so typically Linux commands have options like the -R on the CP command or the -I on the grep command. And this is a case where the options don't always have that hyphen. It's one of the few examples where that is the case, where there are options without a hyphen. Yeah, tar is another one. So there's a very short list, and this is really a sort of a, what would you call this? It's a feature from other versions of Unix or Linux. And over the years, these different versions of Linux have borrowed from each other and have acquired traits of each other. And this is sort of the residue of that process of these different Unixes or Linuxes coming together. Right, yeah. All right, so there are a few other commands that I'd like to show you before we wrap up this basic Linux stuff, and then we'll get into scripting. So one really useful set of commands that I find myself using a lot are pushd and popd. So something that you'll find is when you're working in, let's say I'm here in my home directory, and I have a directory called intro Linux 1. And I cd to intro Linux 1, and I do some things here. I might use ls, I might edit some files, I might run some commands, and so on. And then I need to cd back to my home directory, and then I cd into this test directory. And I run some more commands, and I run date into date file, and I run who, and I redirect that into who file. But then I need to go back up over into this intro Linux 1 directory and do some other stuff. And I find myself bouncing back and forth between several different directories. And I end up spending a lot of time running cd, and I give it the other directory name and so on. And it becomes really tedious and really cumbersome. So the pushd command is sort of a variation on cd that allows you to change to another directory, but it remembers where you are right now. And it keeps sort of a history of all the directories that you visited. And it keeps this history in a structure called a stack. So let me show you here. So let me start in my home directory, and I can push D into the intro Linux 1 directory. And it shows me here, I'm now in intro Linux 1, but I used to be in tilde in my home directory. And so now I'm pwding, and I'm in intro Linux 1. And then I can push D to /test directory. And so now it shows me that I'm currently in the test directory, but prior to that, I was in the intro Linux 1 directory. And prior to that, I was in my home directory. So it's keeping track of where I've been every time I use push D. So then I can use the command dirs. And dirs lists out all the directories that I've visited recently. So if I want to bounce back, if I want to then go back to the directory where I was previously, I can use popd. So this is popping off of this stack the last directory where I was. So I run popd, and now I'm back in intro Linux 1. So I didn't have to tell it go back to intro Linux 1. It remembered from the time I was there. I can popd again, and it takes me back to my home directory. So pushd essentially commits to memory the place where you were, and then popd backs you back out from that stack. So a really common way to use this is to push D to some directory, and then I might push D to a different directory, And so I've got several different directories on that stack. And then if I just want to go back to the previous directory where I was, but keep track of the directory I'm in now, I can simply run push D. And this essentially exchanges the top two directories on that stack. So I can push D, and I'm now in intro Linux 1. I can push D again, and I'm now in the test directory. And I can just push D back and forth. So it's a really convenient way to set up your shell so that you've got, essentially, I've got several different working directories instead of just a single working directory. And I can bounce back and forth between these all day long. So it's really convenient when, say, I'm writing a script in one directory, but I'm executing it and managing data files in another directory. And all day long, I'm going to be going back and forth between these two places. So it's a very convenient shorthand for doing that. Okay, some other useful commands. WC, this stands for word count. And word count is a great tool for figuring out how big a file is. So I can use word count on, for example, geom3.txt. And it shows me in a simple output how many lines, how many words, and how many characters are in this file. So frequently you just want to know how many lines are in a file. So I can say word count minus L geom3.txt. And it shows me this is the line count on all of the lines in the file. You can say word count dash C, how many characters are in geom3.txt. It tells me it has 4,709 characters in that file. So the word count tool is a really useful thing to ask in general, how big is a file? And frequently you're curious about the number of lines of data in a data file, for example. Word count dash L states.dat. It has 50 lines in that file. Okay. Word count's a great tool. So cut is a tool used for dealing with columnar data in a data file. So we use grep to pull individual lines out of a file based on a pattern. Cut works the other way. It pulls vertical columns out of a data file. So let me show you an example of that. Let's see here. I've got star.dat. Okay, I've got a file here called file2.dat. And it has a list of the state names and the capital names separated by a comma. So let's say we want to deal with this as a comma separated value file, and we want to break these two columns out. We just want to get one of these columns instead of the other. So we can use the cut command to say, cut this file based on the delimiter of a comma and pull out the second column of file2.dat. And so it just pulls out the second column, the capital names, and ignores the first column, the state names. So between grep and cut, you can slice and dice your files by rows and by columns. It's a very convenient way to massage and manipulate big data files. du is a really useful command. It's called, it tells you about your disk usage. So if I cd to my home directory and I type du on my intro Linux 1 directory, it's going to tell me roughly how big that directory is. Not only the individual files, but the whole thing. So there are a number of, let's see, sh. Okay, so du-sh, it's giving me a summary in a human readable form. So h is frequently used with Linux commands to say, give me numbers in a human readable form. And it tells me that my intro Linux 1 directory contains 1.8 megabytes of data. So it's really common practice on a Unix system to have to manage this disk space that you're using. And a command like du is a great tool for doing that. Here I am in my home directory. I can say du-sh star, for example. And it will go through all of my different directories here and tell me how big is each one. So I have an intro Linux directory that's 1.8 megabytes. I have a Linux scripting tar file, which is 168 kilobytes. I have a Linux scripting 2 tar file, which is 4 kilobytes, and so on. And so you can very quickly identify directories, folders, files in your system that are using all of your space. All right, let's see. One more command here which we'll use is called df, or disk free. So disk free shows how much space is available on this particular machine. And so when I run that report, it shows me there are different file systems on the machine, and it shows me how much space is available in them, and how much space is free. So the root file system on this machine is 34% occupied. So that means it's 66% free. There's a lot of space free on this particular machine. So sometimes when you're working on a Linux system, you need to find a space to work where you have a lot of space to manipulate your big data files. On the machines at CHPC, by default, your home directory gives you a quota of 50 gigabytes to work with, which is not a lot of space, unfortunately. So you can use tools like du-sh to figure out where are you using your 50 gigabytes of space. And you can also use df to find where are there spaces where I can work. A lot of our systems here have what is called a scratch file system. This is a file system that's designed to be temporary space freely used by all of the users here at CHPC. And so you can ask, well, how much space is available on the scratch file system? And so that will be a good tool to guide you to a place where there's room for you to do your stuff. All right. So that's all I'm going to cover today on the basic Linux stuff. We're going to shift gears and start scripting, unless there's any other questions here. Yes.
Okay, maybe we should pass this at the beginning, but can you give distinction between Unix and Linux?
Right. So Linux is sort of a brand of Unix. Unix is a generic term for a whole bunch of operating systems that have been around for decades, since the 70s. Unix was first created, I think, in the late 60s or early 70s at Bell Labs. And then it was taken on by different universities and different groups to work with. Each different group put their own sort of fingerprint on it, made it unique in their own unique ways. So IBM had their own version of Unix for a while. University of California at Berkeley had their own version of Unix for a while. Hewlett-Packard, which became Dell, had their own version of Unix for a while. Everybody had their own different brand. And it got to the point where when you bought a computer that had Unix or Linux on it, it was generally Unix-like, but they all had sort of different weird little inconsistencies and incompatibilities that made it difficult to write software that would run on Unix anywhere. And so I don't know when the Linux project started.
Linus Torvalds.
Right.
And he, for his computer science class, he implemented Unix for a PC. Yeah? And then it took off, the PC took off, and then also the whole thing took off, and then became Unix with Linux.
Right. So Linux is essentially a brand of Unix, and it's freely available. It's open source, so you don't have to buy it from AT&T or from Hewlett-Packard or IBM or whoever. You can download it freely and install it onto whatever machine you want.
And there are different distros, right?
That's right. So a number of different companies decided, hey, we should get into the business of distributing Linux to people who want it. So if you're a computer hacker and a hobbyist, you don't have a problem with downloading a whole operating system of source code and compiling it and getting to run on your machine. Companies decided, people want to use this, why don't we make it available to people? So it's simpler, they can just get a CD or download the distribution from our website. And so companies went into business, companies like Red Hat went into business doing this and distributing this freely available source code, for a fee, which is a very nice service, great way to build a business. And so there are a number of competing versions now of Linux. So there's CentOS, there's Red Hat, Ubuntu, Debian, SUSE. There are a number of them. There's, there must be a dozen different distributions or distros of Linux now. So we're here at CHPC, we use a version of Linux called CentOS. And it's a freely available, very nice, standard, high-performance version of Linux. Different communities have adopted, have grown around different distributions of Linux. So Ubuntu, for example, is very common at different universities. It's very common with users of smaller computers and software developers, all sorts of things. So depending on what your goals are as a computer user, you might adopt a different version of Linux for your machine. Yep.
But Mac is built on Linux.
So Mac is, and so there is a, under the hood on every Mac is Mac OS version 10. OS 10 is an Apple-specific Unix distribution. And it shares some things with Linux, like the shell and so on. And it has its own unique, weird things that make it work for Mac. So it's tightly coupled with their software development tools, their desktop environment, and so on. So Apple does things a little differently than everyone else, just as Red Hat and CentOS and all these other people do things a little differently. Yep. Yep. Other questions? Okay, great. So let's shift gears here. I'm going to close that deck of slides. Shift gears here. We're going to talk about text editors briefly, and we'll start scripting a little bit. So many times you will be logged into a Linux system and you need to modify some files. Maybe you're writing a document, maybe you're creating a data file, or writing some software, so you're writing some source code, or maybe you're writing a bunch of shell commands. You're committing those to a file because you want to reuse those in something that's called a shell script. And so you need a tool that allows you to log in, to get into a file and change its contents. And this is called a text editor. So there are a number of different text editors available on a Linux system. So one of the older ones, and a very popular one, is called VI, or a version of this is called Vim, V-I-M. And in the past, we have spent a lot of time providing instruction on VI, but VI is not an easy tool to learn. It's a very powerful editor, but for simple use in the Linux environment, it's kind of overkill. And we found it counterproductive to spend a huge amount of time teaching people how to use this thing when their needs are very simple. Maybe they don't need a super powerful tool like this. So we have instructions on our website linked here about how to use the VI editor. We have a, we have a page which is a VI cheat sheet, which is a summary of all the commands. I'm going to show you a great way to learn to use, to use the VI editor, and it's called Vim Tutor. So there's a command on your machine called Vim Tutor. You can type Vim Tutor, and it walks you through the process of learning how to use the VI editor. It takes at least a half an hour to get through. So in your copious free time, some evening when you're bored, you can fire up the Vim Tutor and work your way through. So this is the main editor that I use, and I've used it literally for decades. And it's to the point now where when I fire this tool up to use it, I really don't even think about the commands to manipulate text and move around and search and so on. It's just, it's just subconscious for me at this point. And I find it a joy to use. It's really a very nice tool. When you're getting started though, this thing is difficult to learn. It's counterintuitive, and it's very different from a lot of other tools that you may have used. So if you're in the Vim Tutor, you can get out, you can type the letter :Q. That's a typical VI command to get out of a file. And alternatively, we're going to use a tool called Nano, N-A-N-O. So Nano is a very lightweight, simple editor. It's very intuitive to use, and it's really a nice piece of software. So let's play with Nano just a little bit together. I'm here in my home directory. I'm going to cd into my intro Linux 1 directory, and let's pick on a file. Let's use this states.dat file. Okay, so I'm going to type nano states.dat, and I type enter, and this brings up the Nano interface. We're now editing the states.dat file. And to maneuver around in here, you'll notice up on the first line, on the first letter of the word Alabama, there's that gray box there. That's called the cursor. That's where, if I type, new letters will appear in the file. And anytime I want to make a change to a file, I need to position that cursor to the place, and then I can make changes. So I'm now on the row with Illinois. I'm going to type in the words, welcome to Illinois, okay? So then I can move somewhere else. Georgia is a beautiful place, all right? Then I can move somewhere else. Colorado is my home state. All right, so I can make a number of changes to this file. Now, if I'm done making changes, I need to get out of that editor and commit those changes to the disk. And to do that, I can look down here at the bottom of the page, and there's essentially a little menu here of short keystrokes that I can use to do different things. So if I want to save these changes, I can type Control-O. So this little caret here indicates the Control key is being pressed down. So on my keyboard, I type Control-O, and it prompts me file name to write, states.dat. It's asking me, do I really want to save this as the original states.dat file, or do I want to change the name to something else? I'm going to change it to states.dat.changed, for example. I type enter. Save file under different name? Yes. Type Y. And so now it changed it. So now notice up here at the top. So I'm now editing a file called states.dat.changed. Okay? Not only did it save it as a different file, but it moved me now, so I'm now changing that file, the states.dat.changed file. And the original file should be left unchanged. So there's some other cool things we can do here. Let's see. We have there is a search capability. Okay, so the Control W. If I want to find something in this file, I can say, for example, Control W, and now I'm in search mode. So I can search for washing. And I hit enter and it takes me down to Washington. All right, so I can Control W again, and I can search for ALASK, and it takes me up to Alaska. So you can search around for the search around in a file that way. There's an online help, so you can type Control G for get help, and that puts me into a page where I can arrow around and get help on the whole system. So there's a whole bunch of commands in here that are not displayed on the main menu at the bottom. There's a whole bunch of things here that I've never tried. It's a very good, complete editor, and it's quite easy to use. But generally, anytime you have a number of commands available to you, they'll show those to you at this menu at the bottom. So if I want to get out of the help system, I just type Control X to exit, Control X, and I'm back into the editor. So if I'm done with the editor again, I can type Control X, like right here, and I'm back out to the shell. So it's a really simple to use tool. It's very intuitive. You just use your arrows to move around, look at the menu for the few things you need to do, whether it's to read in a new file, save the changes that you made to the existing file, get out of the editor, whatever. All right. So for all of the shell exercises we're going to do for the rest of today and next time, I'm going to suggest you, if you're not familiar with another editor on Linux, I would suggest you use Nano, because it's a very simple tool. It's easy to learn, and it'll be more than powerful enough for the kinds of things that we're going to do. Okay? So any questions about that before we proceed? Okay, great. So back to our class webpage here. There's a new set of links here, linuxscripting1.pdf and scriptingcheatsheet.pdf, which is one of those handouts that I've handed out. So I'm going to switch now to this linuxscripting1.pdf. See, we don't need that VI editor. We don't need that one. We need this. Okay, so this is Linux, whoops, no, I'm in the wrong one. linuxscripting1.pdf. Okay, Introduction to Linux Part 2B, Basic Scripting. Okay, so we're going to talk a little bit about scripting in Linux, what a script is, why you would do it, the different syntaxes available to us, and differences between bash and tcsh. So first of all, what's a script? So a script is just a collection of Linux commands that are stored in a file. And the utility of this is that, say you're going to execute a series of commands over and over and over. You don't want to have to retype all these commands every time you do it, right? So you can put them together in a file and simply execute those commands together in the file as a computer program, as a script. So to do this, we need to make that script executable, and we do that with those permission settings that we talked about last time, using that chmod command. And these commands within our script are typically separated by a new line, a carriage return, or you can put multiple commands on the same line separated by a semicolon. That's kind of unusual, but I can show you a few cases why we do that. So when you execute the commands in a script, these commands are executed sequentially, the first one, the second one, and so on, either until you reach the end of the file, or you come to an error, or alternatively, if you have an exit command in that script, which terminates the execution of that set of commands. So in my opinion, there are two really powerful capabilities of the shell in Linux. We saw the one earlier, which was the pipeline, the ability to link commands together into ever more complex commands. The other is scripting. So these commands that we're learning comprise statements of a vast programming language. You can write really complex, powerful programs just with the commands you've learned already. So we'll go through a few additional commands that help us do things like control the flow through a script or a program. But this is really a unique capability in a computer, is to use these simple commands we know, put them together into scripts, and then reuse those scripts for ever more complicated tasks. Okay, so why bother with scripts? Well, it's a huge time saver. Rather than typing in these commands over and over, you can simply save them as a script, execute them, and away you go. And so the real question is, when should you script? And so the script, there's sort of a tension between, am I going to invest time in writing a script that I'll reuse, or is it simpler to just type out the commands real quick and be done with it? Well, there are a few scenarios where you really have to script. The first of them is when you're using a batch script, a batch system, such as the one we have here at CHPC. So when you want to execute a bunch of commands on one of our compute nodes on the cluster, rather than on the interactive nodes where we log in, you have to write a script. You then submit that script to the queuing system, and the queuing system takes over from there. It finds the appropriate computer, schedules that machine to do your work, runs the job, and then returns the results when it's done. So if you want to use the batch system, you got to write a script. Other great scenarios for scripting are automating pre and post processing of data sets. So let's say you're working in a lab where you'll have a number of different data sets to process. You need to execute a few commands on those data files to get them ready for processing. And so you can simply write a script that does that sort of mundane pre or post processing on your data files, and away you go. Anytime you're performing lots of menial, soul draining tasks efficiently and quickly. So building input and output files, managing your disk use on the cluster, things like that. Those are great situations for creating scripts. And so how long should you script? How much time should you invest? Well, here's a figure from the XKCD comic strip, which suggests, based on how much time you save with a script versus how often you do this, how much time you should actually spend writing that script. And it's amazing that someone actually put thought into a cartoon to guide us on how long we should write scripts. So what should you script in? So we have two different shells here at CHPC that people commonly use, bash and tcsh. The two, for the basic commands that we've been playing with, the syntax is identical for grep and cd and pwd and so on. The commands are basically the same. But when we get into more complex scripting, you'll find that the tc shell and bash have subtly different syntax that makes certain things more difficult or more easy in the two shells. If you're doing something more complex than just manipulating files, you might consider a more capable scripting language, such as Python or MATLAB. So Python and MATLAB are really amazing programs that can do all kinds of things that the shell cannot do. But for lots of basic stuff, the shell is absolutely sufficient. If your workload is computationally heavy, if you're doing mathematical stuff, for example, you definitely need to shift gears from the shell to the Pythons, or even further into compiled languages like C, C++, Fortran, Java, things like that. Because even languages like Python and MATLAB have their limitations, especially when it comes to heavy-duty computational stuff. So we offer courses in Python. There are lots of people on staff here who have expertise with other languages. And if you need to go that direction, by all means, approach us about that. Okay, so let's back up and talk about shell scripting for now. So bash and TC shell are our two shells that we use here. And to recap a little bit, a shell is really a user interface between you and the things that the operating system can do for you. It's a layer, essentially, a shell around the kernel, around the guts of the operating system that's doing the work on the machine. And these are also programming languages. So we support two different shells here, bash and TC shell. There are some quirky syntactic differences between them. And so when you are writing a shell script for bash, for example, you can't use TC shell statements and vice versa. If you're writing a TC shell script, you can't put bash specific things in there. So we encourage you to learn one shell really well, whichever shell you're using. If it's TC shell, if it's bash, learn that shell language really, really well. If you don't like the shell language that you're using, it's fine, you can switch. So just if you go to our website, you can log in, you can manage your own account there. There's a menu drop down that says which shell am I using, bash or TC shell. And if you want to switch, just make that change. So which shell do you currently use? Well, if you log into your account, you can run PS, for example. That will show you which shell you've got. You can see here I'm running bash. Some of you, if you do the same thing, it'll say TC shell, and either is fine. Here's a little editorial. In my opinion, bash is the better shell because it has some additional capabilities that TC shell doesn't have. But for most things, TC shell is perfectly sufficient. Okay, so this slide shows how you can change your shell. And so you can go in and edit your profile, and that essentially sends a message to us to change your shell for you. And in about 15 minutes, you will be in your new shell. All right, so from here on out, we'll be working with some exercise files that I have in my home directory. And so there's a file there called linuxscripting1.tar.gz in my home directory. So I invite you to go get a copy of that and copy it to your home directory. So you can use this command right here, cp space tilde followed by myunid / linuxscripting.tar.gz space dot. So that copies it to your home directory where you are located. An alternative is you can go and get a copy of that off of our webpage. And so we have a link. This is this link right here. That's the URL for that file on the web. And so you can use that with the Linux command wget. Wget's a great tool for pulling files down to your account off of the internet. So if there's data files, if there's software, if there's documents, whatever out on the web, and you have its URL like this, you can then go grab it and pull it into your account. So I'm going to go demonstrate that right now. Okay, let's see here. Here I am in my home directory. I have my testdir directory here. I'm going to go in there. I'm going to wget, and there's the URL for that file on our website. And it just pulled down the data at 190 megabytes per second. And there we are. There's the linuxscripting1.tar.gz. Okay, so once you have collected the file, you've either copied it from my home directory, or if you've used wget to get it off the web, then you need to execute this command here, tar space xvfz space linuxscripting1.tar.gz. All right, so I'm going to go do that in my home directory here. Okay. So I have this file called linuxscripting1.tar.gz. I'm going to do a tar xvfz linuxscripting1.tar.gz. You'll notice I used the tab completion there, so I didn't have to type that whole big file name. You can use hyphen for tar, you don't have to. Yep. Okay, so when I hit enter, what it's doing here is extracting files from that big tar file. So a tar file is, if you're familiar with a zip file is something from the Windows world, which is a bunch of files collected together into one archive, one compressed zip thing. And this is the same sort of idea. This is a more Linuxy version of the same idea. This tar.gz file is a collection of files that's been bundled together and compressed. And so this tar command is extracting those files. And when I look around, you can see it's created for me a new directory called Linux Scripting 1. Okay, so I can cd into Linux Scripting 1. I can type ls, and I have a few different files and directories here. So is anyone having trouble getting the file? Raise your hand if you're having an issue getting those files. Okay, so we are just about out of time here. Let's talk about the first exercise we're going to do, and then next time we can go over this together. So I'm inviting you to write your first script. This will be in your Linux Scripting 1 directory. And so create for yourself a file, call it either ex1.sh or ex1.csh if you're using the TC shell. This suffix on the file name is one of those extensions that suggests what the content of this file is, whether it's a C shell script or a bash script. You don't absolutely have to use that suffix, but that's sort of a convention in the Linux world. And so to do that, I'll go into this directory and I'll use my nano editor. So I'm going to use my nano editor, fire it up on that file name. It will create that new script. I'll enter the commands, and then when I'm done, I can write it. So with Control O, that saves it to disk, and then Control X, that sends me back out, okay? And so these are the instructions that we'd like you to follow for creating your script and executing that.
So there's one thing that is very important. When you write a script, you have to always tell what kind of language you are using. Because as Brett said before, the .sh or .csh is just a convention. So to really know, the script has to know what language you speak, and this is called this pound sign exclamation mark. It's called shebang in Linux jargon.
Mm-hmm.
And then you tell which kind of interpreter you are using, the bash interpreter or the CSH.
Right. Yeah, that's a very good point. So with all of these scripting languages, whether it's shell script or a Python script or something like that, when we tell the operating system, please go and execute this file of commands, the operating system needs to know, what kind of commands are these? Are these going to be bash commands or C shell commands or maybe Python commands or who knows what? And so this first line that we enter into our script is an instruction to the operating system to say, okay, the commands in this file are for bash, or the commands in this file are for TCSH. So that first line is critical, okay? All right, we're out of time for today. So let's pick up here next Tuesday at 1 o'clock, and we will go do a bunch of scripting. All right, cool. Thank you very much for coming.